Welcome to the Ellen MacArthur Foundation's Disruptive Innovation Festival, a month-long festival of innovation, entrepreneurship, and ideas for designing the circular economy. The aim of the festival is to provide a platform for ideas, giving you the opportunity to not only learn, but also react and engage in a dialogue. As part of the DIF, we have a number of sessions with headliners, thought leaders, and practitioners providing insights into key disciplines or thought processes needed to build the future economy. We're live from Cisco Studios in London, and today's second Handlight session will explore the fundamental paradigm shift that lies at the heart of the circular economy. A shift that relies on positive notions, such as regeneration, in order to move away from the take, make, and dispose model. I think you'll all agree that this is a rather ambitious agenda. That's why I'm glad to be able to count on the support of Bill McDonough to tackle it. Bill, who as the co-creator of the cradle-to-cradle design philosophy needs little introduction, is joining us live via Cisco telepresence from Washington, D.C. And before we go to a live Q&A session, Bill will share his views on the system as we know it, what could become of it, and what concrete project he started in order to turn a vision into a reality. We would like you to be as involved in this as possible, and that's why we will be taking questions live on Twitter. So please use hashtag ThinkDiff, that's Think D-I-F, and I will relay your questions to Bill. But for now, Bill, it's over to you.
Thank you, Josh. I'm here in Washington, and I'd like to look at this idea of disruptive innovation and start first by asking about what about disrupting innovation itself? And the notion that we would look at the world differently as we disrupt it with new ideas, I think, is a critical one. So I'd like to start by disrupting the way we see. As an architect, I like to say the first job of design is to change the way we see. Then we rearrange some furniture and then we build. But first we look at things and we look at them as we see. So Hildegard von Bingen, in the 1100s, glance at the sun, see the moon and the stars, gaze at the beauty of her screenings. Now, think, glance, see, gaze, think. So the point she goes on to say is, what a delight these things are. And isn't that a beautiful thing, that we see this as beauty and delight? And yet she closes with this statement: all nature is at the disposal of humankind, for we are to work with it, for without it we cannot survive. Is this sustainability? So the question becomes, how can we work with it, but also thrive with it? And if we design into it in ways that perhaps are disruptive, what if we actually disrupt the process of innovation itself by bringing to it design principles and value statements instead of simply disruptive innovation? We actually disrupt the innovation by giving it principles. Design is the first signal of human intention. So the question is, what are our intentions? And if we look at our intentions, we realize that if we're science and engineering based, which we often are, then we look at metrics and we measure like we do in economies. And then we quantify. And we look at how to quantify what we're doing, and we end up with benchmarks and goals: less bad, reduced damage, things like that, because we're inside the box and we're doing quantifications. When actually we could start to imagine what it means to do qualifications. And that means instead of simply looking and learning more and more about less and less until we know everything about nothing, we start to imagine less and less about more and more until we know nothing about anything and start over with our values. And so the values I'd like to propose today are, how do we love all the children of all species for all time? And the economy is a tool for that love and that delight and that beauty. Then we need design principles. Then we can set our goals, develop our strategies, tactics, and then we measure. So it's not just metrics. It's also values. It's the generation of revenue that's ecological, economic, and social, not just bottom line thinking or top line. So the question becomes, how do we love all the children of all species for all time? So to give you a sense of where I come from on this, I want a quick personal history, if you don't mind, of things that disrupted my work. And when I was at Yale studying architecture, a very famous architect professor looked at what I was doing and said, "Young man, solar energy has nothing to do with architecture," which surprised me, given the fact that we'd had the oil crisis the year before. So I tried building an experimental solar house in Ireland, a place with very little sun, and went on to do the Environmental Defense Fund's national headquarters in New York in 1984, where we started looking at the materials for health and safety and realized that there was very little information available, and most architects had never heard of a VOC, and probably still haven't. In 1989, I won a competition in Warsaw for a skyscraper right before the government changed, and it ended up in the Wall Street Journal because this is 3 years before the Earth Summit, and we were worrying about climate change back then. We asked that the developers in Poland plant 10 square miles of trees to go with the building to purify air. At the same year, I started to think about what it would mean to design buildings like trees, a kind of negative entropy. If you imagine a log burning and you think all the minerals and the carbon and the moisture are all going into the atmosphere without being able to come back together, we just have chaos. I started wondering, well, if that's physics and chemistry, what would negative entropy look like? And so this was a building designed to make more energy than it required, to operate from renewable sources, be operated by children, grow food on the roof and things like that. And I called it a building like a tree. We want more of them. They're negatively entropic. But while we were working on this, I remember reviewing the children while the engineers were talking with the teachers, and I noticed they were eating the building. So I started to wonder what that was about, and then connected to Dr. Michael Braungart, a German chemist, and started working together. In 1992, I issued the Hanover Principles at the Earth Summit, in Curitiba, Brazil, as design for sustainability and going beyond. And it included respecting relationships between spirit and matter, for example. These are values, not just metrics. At the same time, eliminate the concept of waste. This is not reduce, avoid, minimize. It's eliminate the entire concept. So in 2002, with Dr. Braungart, we issued Cradle to Cradle, the book. And essentially, the principles we work with are everything is food for something else. Use clean energy, not just renewable, as you'll see in a moment. And we celebrate diversity. So the idea that the world gets better because we're here. So first, we imagine that the world is full of nutrition and that we've always understood biological nutrition because that is life itself and us. But in the last 5,000 years, humans have developed another form of nutrition, which we call technical nutrients, and see them as services. And these are materials that can be put into endless resourcefulness. They don't have end of life because they're not alive. They have end of use, and then we put them into reuse. And we have to keep them from contaminating the biosphere. So we have safe, healthy things in both cycles, and we don't let them contaminate each other. Now, in most cases, people are reporting how they're being less bad. In their ecological, social reporting, corporate social responsibility reports often point out how they're headed for zero or reducing carbon. But when we just want to tell the world we're being less bad, is that really being more good, or is bad and less bad? Aren't they just, isn't bad a human relationship, and isn't less just less of it? Isn't it bad by definition? So let's be less bad, of course, but let's also be more good. And if we want to achieve more good, we want to have a new paradigm, I think, which we call the upcycle. And so we look at our charts and we see most people are reporting their goal of zero. And that's like telling the children it's better if you're not here. If I say I'm going to be 20% less carbon by 2020, is that really adequate to the task? And aren't you just telling me what you don't want to do? And isn't that like running into a taxi when I leave this studio and saying, quick, I am not going to the airport? Is this really helpful? So what we're looking at is, let's take these values we have of good and bad. Let's put the things we don't want below the line. And let's start to put what we want above the line. And now we have both trajectories, but they're in the same direction, which is up and to the right. And so absolutely let us be less bad and remove the things we don't want while we increase our goodness and do the things we do want, because the goal can be taken after we've done an essential inventory of our situation. We can then assess where we're going and where we are by creating an intellectual filter, which allows us to see the qualities we want and those we don't. In terms of molecules, it would be toxins. In terms of energy, it would be renewables and clean versus polluting. And then we optimize, and our goal is 100% fabulous, up and to the right at the top there. So the fundamental notion is to reduce the things we don't want, increase the things we do want, do it all at once, and this starts to bring us to the circular economy, which is just one part of this design. It's the economic part, but it has a social and an ecological benefit as well as economic. This is an important notion because we're looking at constant improvement across 5 different categories when we do cradle-to-cradle work. Materials are nutrients. We want them reutilized in new business models and new systems with returns and reuse designed into what's now, so that what's next is designed into what's now. We want to use clean energy, clean water, and social fairness. And this has now been given to the public as a public good and certification program at the Cradle to Cradle Products Innovation Institute. Now, we look at materials as nutrients. So first, we look at our inventories, and we then put them into play, and we start to imagine these. And so we avoid hazardous materials, of course, but we try to work with new materials that are safe and healthy, or materials that are ancient that have proven to be a benefit to society over our history. So we have biological nutrients, things that go back to water, soil, or where in our bodies, might be in our lungs at some point. These are the living world. And then we have technical nutrition. It's my understanding that 75% of the aluminum used by humans since it was put into play in the 1800s is still in circulation. That is a technical nutrient. And so we can design materials that go back to technology. The first product I was commissioned to design was in the early 90s by Steelcase Corporation here in the U.S. And we looked at it and brought in, Michael Braungart came and worked with us chemists, and we started to look at this idea of what about treating these textiles instead of something that, like this river in Indonesia, caused rivers to turn black. If we redo the chemistries, we work with good materials, in this case wool and ramie, and we treat them in ways that are respectful of nature and human systems. We end up with water coming out of a mill in Switzerland, clean enough to drink, like Swiss drinking water. And this is the water regime of Lake Constance, where this mill is located. And the idea that you could make fabrics whose trimming are made into mulch for the local garden club instead of some toxic waste that has to be shipped to another country is the kind of strategy that we're dealing with here. Now, when we look at that as a system, we realize we go from something producing waste that's hazardous to something that is a nutrient over and over again. And the fabric is clean enough to eat. The water is clean enough to drink. This is the new design. We bring that same thing to technical nutrition for carpets. This is the case of Shaw Industries in this case, but we also see Deso in Europe and so on. These are not PVC carpet. There's 1.3 billion pounds of carpet waste in the United States. If we just recycle it, we would be using materials that are highly suspect in terms of carcinogens and furans and things like that. So instead, the carpets are designed to become carpet again, and specifically designed with face yarns and backings that are endlessly resourceful and ready for circulation. So this is the back of one of their carpets. And so you work with your customers to store your materials on their floors, in a sense. We warehouse our raw materials on the customer's floors with take-back systems. And so before, we used to design things that ended up in waste material systems, and now carpets become carpets again, and not just get reused as a substance that is of concern, but substances that are fully defined for optimization over generations, a whole new way of approaching it. So with materials, we talk about reuse, new business models, reverse logistics, and we also talk about reducing the things we don't want. Now, as you just heard, this is the take, make, waste world turned on its head, because what we do now is say, let us mine the past for the future instead of nature, because we can actually take from the waste, remake things, and then restore the world in the process while we bring back the living systems that have been damaged. One very elegant example, I would say, is this. We call it either or. And there's a chemist, Michael Krasinski, who has found a way to extract rare earths and precious metals from circuit boards in a way that allows them to be valued and become ore in a sense. And so you can choose, as we see with all these different systems, either or. You could mine the earth and get, in the case of gold, $210 a ton. Or in the case of circuit boards from telephones, you could get $7,560 a ton of gold. So take your pick, either or. And so in the next revolution, we see using these materials and systems as pools of materials that are used across generations. So early clients for this included Steelcase back from the early 90s, and Herman Miller, two of my clients here for design. I've even designed Herman Miller's factory where these are made. And the chairs are designed to be taken apart whenever, and their materials, the aluminum, the polymers, and so on, go back to usefulness. Now, if we look at that as we're now looking in the United States, at the whole system in the United States, this is a drawing from my office. We're looking at the United States and all of its so-called waste, and looking at it and imagining it being defined in these various circuits of nutrition. And it's sad to see how far we have to go, but great to see that we can start to imagine things in this way. Now, as we move on to energy, after materials and logistics, we start to see that we can watch renewable power become cost-effective in many places, certainly with wind and solar dropping in price. But we also see energy efficiency and reduction of CO2 emissions as being something that is being taken up vigorously. But we also have some interesting news as people start to imagine this future. And I think something earth-changing happened very recently. On October 8th, a paper was published, and this is the title of the paper. And this is something that I think can bring hope to us, because it appears that there are things coming that we can now start to imagine might be of immense value to us. This, an observation of abundant heat production from a reactor device of isotropic changes in the fuel. What does this mean? Well, it was a review by scientists who authored this report, and this was published in scientific journal. And here we go. Listen to this. In summary, the performance of the reactor is remarkable. We have a device giving heat energy, but operates at low temperature, low energy, and gives neither radioactive waste nor emits radiation. From basic general knowledge of nuclear physics, this should not be possible. Nevertheless, we have to relate to the fact that the experimental results from the test show heat production beyond chemical burning, and there's some nuclear transformation. No radioactivity, right? It's certainly unsatisfying. The results have no convincing theoretical explanation, but the experimental results cannot be dismissed just because of a lack of theoretical understanding. So think about circular economy, for example. Kenneth Boulding made the quirky remark once that an economist is someone who's trying to prove that something that's happening in practice can work in theory. Well, this is something that just happened in practice, and we don't have a theory. But it's very hopeful because we imagine that humans are excited about cleaning up and doing amazing new things that benefit us all. So, in terms of water, we can reduce water consumption. Certainly, we can minimize toxics, sure. But if we're still putting toxics in there, even if we use tenths less, it's still toxic. So the question on water becomes a question of design as well. In Rajasthan, we've just finished a factory design that's now under construction and has been erected that is using a structure for solar collectors because of the bracing, but in the space between greenhouses. And we're looking at every piece of it as part of a system that's coherent. It does 8 things at once with each molecule of CH4, whether it's from natural gas or from biogas. And it makes electricity, water out of the air, cooling, heating, oxygen for the workplace, CO2 for the greenhouses. It makes jobs, it grows food. So how many things can we do at once as we do this and make water, distilled water from the air in a desert? Imagine that. As we look at this idea of clean water, for the River Rouge project for Ford, this is more than 10 years ago, we were looking at the site you see on the left, and that is a color photograph. And on the right, what we ended up doing is the world's largest green roof. But the important thing in terms of the economy was by using these systems instead of chemical treatment plants over the conventional chemical system that had been planned and was ready to be built. This system allowed us to save $35 million in capital expenditure that would have been underground and in chemical plants, because we used the natural systems and the restoration of ecologies as the system that would purify the water. A $35 million capex savings for a company that makes automobiles is the equivalent of getting an order for $900 million worth of cars at a 4% margin. This is the economy. Now, as we look at the water and we look at our manufacturing, this is a picture from Hunan province in China, apparently taken quite recently. It was in the Yale Journal, and they pointed out that China has recently announced that their soil is now contaminated to the extent of 19.4% of their arable land, which is only 12% of their land mass to begin with. 20% basically of Chinese agricultural land is contaminated with things like cadmium and lead, the materials that we have in our batteries, for example. So what are we doing out here? And is this our intention? And when we poison the soil, we poison the water and so on. When we mine, we could mine the gold, and we know famously that gold mining is chemically very, very awkward to even imagine in so many places. And we could start mining what we made yesterday and start to find ways to heal the ecosystems where these minerals come from, etc. So finally, we look at social fairness in Cradle to Cradle. And so the notion of leaving behind a beneficial footprint on the global community is fundamental. So it's not just a question of complying with regulation. Regulations are signals of design failure. When society has to step in and say, please reduce your badness, it's because it's concerned. So regulations are obviously a very important expression of society about their concerns. But for design, what if we design things like that textile where the water coming out of a textile mill is drinkable? Well, then it doesn't need to be regulated. Isn't that interesting? And for business people, a regulation is a cost, and it doesn't necessarily generate revenue. But what happens when you design things that are safe enough that society isn't anxious about it, and then you can get on with your business? Now, this changes the nature of the dialogue around commerce itself and the economy. It changes the question of limits and fear and greed, which is, how much can I get for how little I give? This is the current question of modern commerce. And it's a commerce of taking. And nature never sent a bill for the trees and for the minerals and the water. They were there for the taking, and they are still being taken today and put into commerce. There we are. And here we are in the modern world. But what if we imagine changing that dialogue from taking and limits and fear to giving and abundance and generosity and fairness and peace, because peace is the absence of fear. So what if we have a culture of giving that translates into commerce? The question becomes, how much can we give for all that we get? So I want to just take a look really quickly as I close at a doctor in India, Venkataswamy, who passed away a number of years ago. He was a cataract surgeon, and he realized that it was quite expensive to get cataract surgery, and he realized that with his skill, he could do a cataract surgery in 10 minutes. And why were the little lenses hundreds of dollars? And what if he did mass production of eye surgery? And what if he could bring the price down because he's doing a lot of it? What if he did enough of it that he could build his own factories to make the lenses go from hundreds of dollars down to $2 or $3, $4? And this is what he did. So his legacy is that millions of people have been given eyesight, even for free. And the people who could afford it have paid whatever it took to get the rest of the system accomplished. So the people who could afford it might be paying $100, and the people who can't afford it get it for free. A culture of generosity, of benefit, and of mass production that benefits everyone. And everyone gets the benefit of it. So when we saw Haiti and Pakistan, when we saw the earthquake and the flood of the Indus at the same time, it became something that occurred to me as an architect. Perhaps there's something we could think about here. And in the first Industrial Revolution, if we looked for materials that were free, or even cheaper than free, well, what would we look at today so that we could benefit the most people? And if we look at what we currently call our waste systems, we have the detritus of our modern production everywhere. It's massive, and it's astonishing resource. It's highly questionable. It's an undefined system. I'm working with the various waste industries to help identify what these are and what they could be in the future. But I can tell you now, most of the things that come through their filters are known as contaminants in the waste industry. They're all contaminating each other, and we see them contaminating the natural world. And so what if we could mine these things and park them temporarily for some benefit? So it occurred to me that perhaps instead of putting people just in tents and 50 million refugees, my goodness, what if we could start to imagine materials and systems that sequester some of the things that we made in the past into useful forms, and that the people who receive these as a rescue mission can actually be getting capital formation and elements of things they can take with them and use for housing and things like that, and transform into their cultural expression of a dignified home. So in the Indus Valley, it might be mud huts. In Haiti, it might be decorated houses. But I started to imagine the children even getting involved in helping redesign their own communities, and started working with school kids who were laying out what they thought a village might look like if it was renewably powered, made of safe, healthy materials, and so on. And I started to imagine, what if we could take these things, and they're highly conceptual, and just start to make things where a family with their children could build a home, a dignified home, and get the core of it built in one day without tools. And that we could develop things that could magnify themselves. This little module can become an 8-bedroom house. This is the highly conceptual version of it. And they could create neighborhoods with these things. And I'm well beyond all this now. We're studying all kinds of different systems that would allow for people to express their own cultures everywhere using these various materials in new ways. And so your cultural expression could be as it is for your history, your spirit, matter connections. We can develop appliances and things like that. But let's house 2.5 billion people who don't have a dignified home. Because I think a dignified home, like clean water and things like this, and now perhaps even clean energy, is a human right. Let's think about it that way. How can we give it to people when they can't afford it for free? And the people who can't afford it can help those people by having a dignified relationship that is at scale using circular economies. So I think it's perhaps time to mine the human past instead of nature for the human future. I think we have enough material there. I think we can start to wage peace instead of war with each other. And we can wage peace with the planet instead of looking like we're at a fire sale as we destroy and take. We can also wage peace by design and show our intention in that direction. And we can do it fiercely because it requires that now. And when we see the people who are doing this work, and as you'll see in this festival, these are the warriors that are bringing the gifts of peace to everyone while they behave in principled ways with positive ambition for benefit for everyone. And they wage peace using commerce as the engine of change. So we are here, of course, and we are here to hope we can help heal the earth, indeed. But in the end, we are here, but it is the earth that will heal us at this point in human history. Thank you.
Thank you very much, Bill. That was extremely insightful. Thank you again for that great presentations. Questions have been piling in, and as I was receiving them, I was thinking, well, I'm going to have to disappoint some of you because obviously we won't have time to go through all of them. Let me start by a sort of historical perspective. You talked about the Earth Summit in '92, publication of the book in 2002. over the course of these years, what do you think has been the take-up? How do you assess progress made around these ideas?
Well, I think like so many things, these things take a long time. The new book, The Upcycle, came out 2 years ago. And so sort of every decade we're seeing this. I think the fact of this festival itself is a testimony to the notion that the ideas have spread broadly. And I think, as Thomas Jefferson said, an idea will spread like fire. And then we see it being taken up by various places over time. I received a letter this morning from China asking to help integrate these systems into their economic structure. So that's an important notion. But we're seeing an essay of clues. It's showing up everywhere, all over the place.
Great. Well, that provided me a fantastic transition because there are actually quite a few questions about China. You mentioned during your various public talk being involved with the government and doing a lot of work on the ground there in China. Can you provide us a bit of an overview of what's happening there, what's likely to happen, what kind of sense of scale are we looking at?
Well, I think that China had a circular economy initiative for their economy, their 12th five-year plan, which ends next year. And there have been a lot of attempts at various levels, that have been successful, unsuccessful, so on and so forth. This is normal life. But what's exciting is I think the Chinese have recognized, given the situation they're in now, that they look kind of like the United States looked back in the 60s in Pittsburgh, or London might have looked, in the 50s when you couldn't see across the street, So it's not like they're going through something we've never seen before. In fact, I think they've essentially caught up so quickly to the current systems that it's an exaggerated version of what we saw in the first industrial revolution in Western countries. So I think China is ready to do something at scale, but we're seeing all of it happening at once. The best of it, the worst of it, just like so many places. So it's very hopeful, though, because I think Chinese leadership has now recognized this is a fundamental key issue to integrate into the economy. So I think it's very hopeful.
Thanks, Bill. A lot of questions focus on education, obviously, and something that strikes everyone is you talk about those new materials and the problem that some of the materials our linear system has created lands on our doorstep. So now the question is really, if you go and study chemical engineering at university at the moment, are you being taught about those positive materials? Do you actually come out equipped with the tools to put better things in the system?
That's a great question. The reason I think that will come quickly is because of commerce. It will be asking for these things. I think that's why the Circular Economy Initiative is so important, because what's happening here, the companies that are engaging in this question will be putting out the request for the people who come to work with them to do things this way. And so I think if the academic and the training programs around recognize the demand for this kind of thing, they will be looking for how to train people to meet that demand. So I think it's a very important part. And we're going to be undertaking a major education initiative for China, for example, very soon on these matters, because people do need information. They need access to the tools. It's an important part of the rollout.
And of course, that begs the question of business engagement also to make them understand there's value in that model. What framing do you use? How do you position it? Let's say you mentioned the Ford complex, which was a massive undertaking. Was the economic argument the only thing that they were responsive about, or did you use a mix of different narratives? What's your way of pitching that story to business to make the impact?
I think that's a great question. I like to start with the values. And in that case, we said, basically, this project's for the birds, and that is true. So we looked at what it meant to restore ecosystem, and then knew that when the time came to get approval from the board for its economics to get it built, we would have to make the economic case. So at the end, it turned out to be a CapEx, a capital expense case, that we could save money by doing it this way, and that would be a benefit in cost. Now, every factory in the world, same kind of thing. You got to remember, this was a Clean Water Act site. They were required by law to do clean water. So there was a budget for chemical treatment plants to clean water. Most sites don't have those budgets to worry about, et cetera. So you might have a different response. So all sustainability, like politics, is local. And in that case, we made a local case for biodiversity and ended up making a capital expense saving that allowed the project to proceed. So in the end, the money matters a lot. And that's why the circular economy is so critical, because it's the economy that often drives the decisions, and we have to honor that. So we like to position our designs as economic equations after we meet all these design principles and see what we can accomplish creatively.
Yeah, so obviously that comes back to a point you made earlier in the presentation with regards to commerce and the very notion of it and the way it evolved. And nature never sent a bill, either for materials or services, etc. So I think one of the questions that's been around for a while now is that of full cost accounting for ecosystem services, valuing that capital. How crucial is it to actually achieving that circular model?
I think it's a very important part of the story, and we're seeing a lot more and more, and a lot of that more and more. The idea of valuing ecosystem services. Clearly, the city of New York would not be able to afford to build a water treatment plant that could perform as well as the Catskill Mountains, where the water comes from and gives them the drinking water they need. I mean, as an economic equation, it's phenomenal. So ecosystem services are a critical thing to assess in the money universe, of course. And it's part of what we do, but I think not what we do, but I think it's really what a lot of the institutions are looking at very carefully, and it's very critical in a lot of the businesses. But the real question for us too is that we can cascade from that, literally, from those mountaintops, and come down looking at what the natural systems are doing in terms of providing various utilities as well, but keep going down to the parts per billion. And look at the whole system, but also look at the small parts of the system that make it up. And then we look at the whole system and realize, like with the gold, we probably don't have to be mining that gold now if we use yesterday's mining and repeat the story. So these kinds of things become quite critical.
Thanks. Let's go back to education, because we have a lot of questions around that, obviously. So what advice would you give to a design student who's interested in designing things to be made again, that regenerative loop? So how would one go about that in terms of pure ideas and ways of thinking about stuff, but also in terms of education? Because where do you go to learn that?
That's a great question. We don't really have places everywhere that teach this. We're all getting in situations where we can help from the experience. But I'd say the first thing, you follow your own passion and find out what you find beautiful. Because in design, if you have that passion, if you have that set of principles, that will help you. Then you look very quickly at what you're designing. Is it a biological nutrient or a technical nutrient? So if it's going to be in the biosphere, do you have access to information about healthy materials that are going to be in your system, like textiles you're wearing or something? And then if it's a technical nutrient, define that and then design it so you know what's next. Like we've seen in some of the videos in this festival, there are people designing things to be taken apart so they can easily go back to systems, And the idea that you could design things that have returns logistics built into them, packages that can be returned, materials that are being picked up by the same truck delivering the new product and taking it back for remanufacturing, things like that. Design into what's next, what's now. And then for education, I think like so many things, it's about your curiosity, and go learn about the things you love and then get really good at that and look at it with these lenses of economic, ecological, and ethical relationships, and there will be more and more places where you can learn these things, and just follow your bliss into it. That's what we need.
Yeah, and back to the economy, do you identify certain sectors that will be maybe the easiest ones to go for in terms of maximum impact? What are the quick wins, if there are any? Do you need to focus on one, or is it a completely transverse kind of way of looking at things?
I think it is all one thing. So it is transverse. It is, because they all affect each other. For example, as we look at the healing of the earth itself, say in China right now, where we see this heavy metal contamination and so on, as we move in to heal that, the science of that is going to be amazing, because how do you deal with something like that? Well, that affects the water. The water affects the cities downstream. Working upstream from that, it affects the food quality. The food quality reflects people's anxiety in society, if their food safe, and so on and so forth. So all these things are connected. And why is it contaminated in the first place? Well, it's heavy metals. What were they used for? Batteries and children's toys that were exported? Really? So that affects electronics. It's all connected. So I think there's the places to start. I think textiles, first industrial revolution, start with textiles. I think textiles are a very good place to focus. I think electronics are a really good place to focus, because it's so obvious that we want them back. We're going to churn them. I didn't buy this computer or cell phone and expect it to last me 25 years. I expect that to be going back into technical cycles. I don't want it thrown into some river. It doesn't make any sense. So I think electronics, textiles, all the basics that we have in industrial production of that kind. And then the more subtle ones, the polymers, the plastics. Right now we see people saying, well, I have a bioplastic or a bio-based plastic, and I have a regular plastic, and isn't it interesting? And you see all these things get mixed up. And as we look at the systems for logistics, they're all contaminated by each other. So I think that whole system is ready for a major redesign in terms of optimization of polymers and the carbon that's solid form. Because if all we do is burn it, then it's back to the atmosphere, and that's backwards. So I think this idea that we see carbon wants to be earthbound, not released to the atmosphere, is a fundamental design thing. And that one will reflect on solids as well as gases, as well as pollution, and so on.
And how about the built environment, which is obviously extremely materials and energy intensive and weighs a lot in a country's material flow over the course of a year? And I'd like you to talk more specifically about obviously the materials, but also the new business models around those buildings. Because we see emerging ideas around leasing some of the materials that are in them, which is enabled by IT, so you can track those assets, know where they are, and plan for their next use. Do you have any concrete case studies to share with us?
Well, we're underway with that right now in the Netherlands. This is something that, Michael has called buildings as material banks, which I think is a nice way to express it. But this is part of our design for disassembly. Now that we have the tools when we design our buildings to know every part of it, we design it now with signatures on everything. And what's fascinating is if you look long term, and as the developer I work with, Kurt Zachariasa, I think is actually presented in London on this, we look at the materials as future commodities. And when you do that, your financings even get different. Because if you look at concrete and steel, they've always been together in pricing. And then now steel has become a commodity. So we can expect that at the end of a 15-year financing term, that if the building was leased again, well, that's nice. We perpetuate its use. But we can also design the building to be converted to housing. That's a reuse in a different form, right? Which is marvelous. But finally, if it has to come down and we need to build something new, if the materials can be sold, they're worth about 180 euros a square meter to everyone. If the building is torn down and it's concrete, it costs you 80 euros a square meter to tear it down. So look at the difference in that. And all of a sudden, when you design what's next into what's now as a material reuse scenario, the financing in the current terms is better because you're not depreciating the building. You're actually watching the materials appreciate in value. So it's a whole different finance model, which is quite amazing in markets that are very tight and things like that. So there's that. I also see the design of things for reuse, like offices as housing and things like that, are part of the same story. It's about doing those kinds of things. So we've found that people, if I design a building you could live in, you can work in it, but it's not necessarily vice versa. If we design an office building with large floor plates that couldn't get windows and apartments in them, then the building can't be converted to housing in the future. So you end up with these beautiful synergies that start to show up in current design relative to designing in the future. The other thing to remember, China apparently has used in the last 3.5 years as much cement for concrete as has been used in the United States in its entire history. China has used in 3.5 years as much cement as have been used in the U.S. in its entire history. That tells you something.
Yeah, it does indeed. And it also raises a question of that urban development, which in some ways has to be linked with urban planning, which is an infrastructure and a governmental issue, municipalities. So how do you see the implication of cities in that shift to a more circular model?
I think the first thing, and it's a hard thing to do, but is to reconnect the notion of the city and the country as one organism. When I was a baby, I was born in Tokyo after the Second World War. And we used to hear the ox carts come in from the farms to collect our sewage at night. And it was a chance for little babies to celebrate, because poop stories, and it was fun, the farmers coming to collect the sewage. And we thought, well, this is great. Our poop goes off to the farmers and comes back as food. But I've always thought of the cities and the farms as one organism. So I think we have to re-engage that question. And one direct example would be converting the concept of sewage treatment into nutrient management. So instead of having sewage treatment plants in the cities, where we take the phosphate, the nitrogen, and so on, and then run them through a sewage treatment plant, add chlorine, and throw it in the water, instead of polluting the local water and losing these nutrients, and we have to go elsewhere for phosphate, for example, what if we turn these into fertilizer factories like we're seeing now, where we can recover phosphates as struvite, we can recover nitrogen, we can even create methane that we could use to make polymers again instead of burning it into the atmosphere. But we could imagine sewage treatment plants becoming nutrient management systems in cities. And all of a sudden, we've got cities providing fertilizer for farming. Isn't that amazing? And it's slow release, so it doesn't poison the water every time it rains like it does with regular phosphate. See? So all of a sudden, the city and the farms become one organism once again. That's fascinating. And if you take all that plus these new potentials for clean energy that start to give you amazing opportunities for endless resourcefulness, that's one thing. The other would be to have the new parts of cities get to fix the old parts as a license to build a new part. So if I want to build a new building outside Beijing, for example, what if I could say, in order to get the water and the energy I need for a new building, there is no more in the watershed. There's no more in the groundwater. There's no more power available. It's, of the conventional kind. What if I make a building inside the old city become energy effective in new ways to allow me to build this one? And if I did it 2 for 1, at the end, you could double the size of a city, as they're about to, but you're using 25% less energy and water in total. So the city got twice as big, but you're using 25% less energy. Isn't that amazing? And then if you add these new forms of energy, the renewables and the clean energy and the clean water things that we're doing, that perhaps the whole organism in the next 100 years becomes, a positive agenda with a beneficial footprint. Wouldn't that be exciting?
Yeah, that would indeed. But when we look at the nutrients management and what you say about capturing some of what goes out, essentially the system as it is today, for lack of a better word, we're looking at a big flushing mechanism. So what does it actually mean in terms of redesigning the whole pipe system? Are there any figures on that? Did somebody do an analysis?
Yes, I would look right away, for example, on that one at City of Vancouver, where the people running the sewage treatment plant invented something because they were trying to get the pipes to stop clogging up with minerals. So they said, if I take the sludge and I shoot it through in a vortex, maybe I could get the other end without the pipe clogging up. And they ended up capturing struvite looking like little pearls. Now they sell it. So essentially, these things are showing economically to produce about a 12% financial return for the sewage treatment plant. So I think, again, it comes back to the money. In the end, the idea is great. And the concept is great, but the question is it cost effective so that people will do it? And I think they've proved that, which is the exciting part too, is that if it produces about 12% economic return. Now, cities make money from the sewage treatment plant. That's interesting. See, that gets the mayor excited and the people excited, because now instead of the city citizens paying to have somebody take all this and throw it away and make a problem, now they're actually getting revenue for selling their poop. Wow. Isn't that exciting? So it's just a flip in the system. But the economics matter, and they're the thing, I think, that'll make it get taken up vigorously.
Great. Let's stay in the city, because I have one about the rise of 3D printing, decentralized production, repair cafes. How does that fit in the whole picture? I suppose there's a social aspect, an economic aspect, a materials aspect as well?
It's got all three. That's pretty exciting. But, I think that we like to talk about it as there are things that you need, there are things that you want, and there are things that you love. So you might need, a zip car, or you might need small, quick transportation. You don't need to own a car, for example. The car you want or transportation might be a high-performance automobile for whatever at some time. And the one you love is something you inherited from your family or something, and you want to caress it. So I think the idea of reuse cafes has more to do with socially than a lot of other systems. A chance to get together and be neighbors as well, get help from people and have fun and learn how to use a screwdriver. So that's nice. And then I think the other thing that we're seeing in the economics are that a lot of things can be shared. There's a whole new sharing economy coming where people can essentially say, I have more of this than I need, and I can share it with someone else. And those kinds of things are watching those things come. But for me, I think the part that matters as much as anything is the notion that we call ourselves consumers, but most things that we get, we don't consume. You can consume toothpaste or a banana, but not a computer or a car. So I think the idea that we would say things that are designed in biological or technical cycles become inherently valuable, and they're values-based, and then they can be shared in new ways across generations. That's the part to me that it's not just the experience, which it can be delightful, of sharing with people and experiences, which are so valuable. But you're also, by reutilizing things over many generations, we're allowing us to share a beautiful world with many species. And, what happens when you think like this? I'm designing a building now where the design is 2 sheets of glass for the lobby. And for the decoration, we have shelves every 2 feet with butterflies hatching. So you get to spend the week going to work and watching butterflies hatch. And they're the ancient butterflies that are going extinct in Barcelona. And then on the weekends, the children can come to the outside wall and open the windows and release the butterflies into Barcelona. And then they can go out and tell the highway department, why are you destroying butterfly habitats? They can go to the parks department and say, wait a minute, our butterflies need these, things like that. So all of a sudden we reconnect. Why couldn't a building restore biodiversity? Why does it just have to be a little more energy efficient? See? And all of a sudden everything becomes part of the organism that is life itself. What a pleasure.
Right. Since we're talking about organisms and living systems, I'll just squeeze in a last question before we close, but it's a very interesting one. There's some great potential in research in new materials, yet living systems only use a limited number. We seem to have exploded that limit. So is there any merit in trying to limit or rationalize the palette of material we work with in the economy? And if it is, how would you go about that?
That's a great question. I would take a look at a new battery that has been invented and take a look at their protocols for how to design it. They said we need a battery and we need to make it from materials that are readily available and almost ubiquitous and not obscure or toxic, So you don't just say I'll use anything to achieve this. They said, what can I use that's safe and readily available? And they ended up making it essentially out of seawater and paper. And just because they took the approach you're just describing of saying, perhaps I start with a simplified palette of things that we've seen that are readily available. Quite astonishing. So I think that's right. And for disruptive innovation, Paul McCready, who invented the Gossamer Condor, the first human-powered airplane, and he won the Kramer Prize with that. It had to fly a quarter of a mile above the ground, I think, and then turn around to pull and come back. And he did it with human power. And when they asked him afterwards, how did you do it? And he answered, I had to have 3 conditions. 1, I needed the money. It was a 100,000 pound prize, I think. He needed the money. His brother had borrowed some money and didn't return it, so he needed it. The second was he had to imagine he had never seen an airplane before, because any conventional aerodynamic solution was too heavy and couldn't be done with human power. So very lightweight. But third, he said it had to use any material that he could find, regardless of experience or cost, to achieve his goal. So he couldn't imagine, he would just use mylar and bits of wire. Now, that last one, any material, regardless of experience and cost, I think the questions being asked here is a fundamental one. I think it's material, regardless of experience or cost, that is safe and healthy across generations and does not produce toxic conditions by being a material in the wrong place at the wrong time. Because a toxin is a material in the wrong place. And so I think we have to bring that to bear on our material decisions as well. So I think simplification, yes, but principled innovation, yes. Give us choices. Give us good choices.
Thanks very much, Bill. I think, unfortunately, we've come to the end of the session, so I'd like to thank you very much for providing those perspectives on kickstarting a new wave of economic development. Thank all of you for dialing in from around the world, and of course, thanks Cisco for providing the technology to make the session possible. I would also like you to be aware that the next session will be Jeremy Rifkin on the 30th of October at 1700 GMT. That's 5 o'clock in the afternoon GMT. And Jeremy will talk us through the model of a third industrial revolution. And for now, have a good evening, morning, day or afternoon, depending on where you are in the world. Thank you very much for joining. Goodbye.
What if the next big thing isn't a thing at all? It's lots of things, all waking up. Becoming part of the global phenomenon we call the Internet of Everything. Trees will talk to networks, will talk to scientists about climate change. Cars will talk to road sensors, will talk to stoplights about traffic efficiency. The ambulance will talk to patient records, will talk to doctors about saving lives. It's going to be amazing and exciting, and maybe, most remarkably, not that far away. The next big thing, we're going to wake the world up and watch with eyes wide as it gets to work. Cisco, tomorrow starts here.